Kicking things right off with the 2015 Level 2 Organic Chemistry. They don't really give you much in the terms of formulae or resource sheets or anything like that. They do give you a periodic table, and some of the chemicals that you'll need to know are on that. But with that, there's not much to it. So let's do it. Question 1. So question 1, let's just sync this up a little bit better. That's better. Question 1 wants you to complete the following table to show the structural formula and IUPAC name for each compound. Okay, so this one has an amine and it's on the first carbon. In other words, it's propane. So let's draw our 3 carbons there using lots of space, and it's going to have a nitrogen there. And what's it going to have? This one's going to have H3. This one's going to have H2. This one is going to be connected to this one, so it's going to have H2 again. Yes, I think so. And the nitrogen itself is going to have H2. It has, of course, one less place where it can put those electrons. Okay, chlorobutanoic acid. 2-chlorobutanoic acid. So it's got chlorine in it, and it's butane something. And it has an acid. Okay. So, what do we want to do? We'll start from the left, actually, doing this butanoic acid, because that's what's going to come up first. So it has to have an OH going to carbon, and then that double bond to the oxygen. That's that. Second bond has to go to carbon, and that's 2 chloros, so that's going to have a chlorine attached to it, and 2 has to have a hydrogen as well. I guess you could put the hydrogen here, couldn't you, since we're kind of doing it that way. The hydrogen here, and then another carbon here, and that's going to have, is it going to have 2 hydrogens? 1, 2, 3. No, it's just going to have hydrogen. This is going to be H2, and the last one is going to be H3. So does that BU monkeys eat peel bananas? Yes, that's right. All the hydrogens are correct because it's got that bond to the chlorine. Yes, correct. Okay. What is this beast going to be? Well, it's alcohol there, and it's got a methyl group here. So that means their reference carbon is going to be there. Right, so this is going to be methyl 1, 2, 3, 4, 5, 6. Methyl, and then an ol has to have an alcohol. Now, what number are these? This is on the second one, and this is first, second, third. So this next one can look a little bit tricky. It almost looks like a chiral atom, like around the center, but if you notice, these are all carbons. So the longest carbon chain is going to be, the longest carbon chain is actually going to be that chain there. So with that said, this bromo is attached to the second, and this now becomes a methyl functional group and a bromo functional group. Oh, and they're both attached to the second carbon. So this is going to be 2 bromo, 2 methyl. This this here is on a chain, even though there's carbons either side. And there's nothing attached to that. So monkeys eat peeled propane. And no, they're all single chains. There, so that's a tricky one. Anyway, next. So now we're told that the organic compound 4-chloro-3-methyl-pent-4-ene is named incorrectly. What does this imply that we're doing? I can tell you just by looking at it that this ene, this double bond, has to take priority over the chloro and the methyl branch. But let's have a look and see what they're talking about. So it would be CH3. So there'd be 1, 2. And then I guess you would have the methyl attached to that. C, and then I guess you would have the ene, the double bond there. And that would be wrong because your reference carbon would be there. And the fluoro would take priority, and it doesn't. It takes priority over everything. So our true reference number would be that one there. So it would look, I guess it would kind of look, well, I guess we could do it the other way. It's going to be CH2, then the double bond, and then the carbon, and then the single bond, and then that one there has this methyl group attached to that, and there's I'm missing that. There's a chlorine, doesn't it? It has this chlorine bond there. No, it's going to have that there. Going to have that there now. Hang on. It should be on here. It's going to be like that. Like that. 2 CH3 CH C double bond. Okay, yes, that works for me. Okay, and the name of that is going to be 2-chloro 1, 2, 3. No, I've got that wrong. I'll take that back. I should go to that one. Yes. 3 methyl pent, and that's on the first one. 2-chloro 3-methyl pent 1-ene. Clear as mud. Right, the next question asks us to identify some colourless organic liquids: ethanol, ethanoic acid, hex-2-ene, hexane-1-amine. Okay, and they give us acidified dichromate solution, bromine water, and sodium carbonate solution. In your answer, you should identify the test reagents used, describe any observations you made, and identify the type of reaction that occurs. Identify the organic product of that reaction. Well, that's interesting. Okay, so we're going to presume for this that we have unlimited amounts. Okay, and we can put them in different containers. The first one's going to be pretty easy, actually. It's the ethanoic acid. So we put the ethanoic acid into a container like that, and into it we put the sodium carbonate, which you should be able to find in your kitchen. And when you put it in, it will bubble vigorously, let off vapors, and go all foamy, probably. If you've ever made Anzac biscuits, you should know what I'm talking about. What is that going to make? It's going to make Well, it's going to make CO2 gas. It's an acid base reaction, and the sodium is going to split off. So it's going to form, what is it going to form? It's going to form CH3 ions. Okay, so the ethanoic acid is fairly easy. The bromine water. Okay, so we have the bromine water, which is water with bromine in it. We've got three little pots of that in it, of the bromine water. We put each of these remaining three into it. So there's ethanol. We put the hexane, and we put the hexane 1 amine in it. Okay, so we put that one and that one and that one. My phone is going. Okay, so these are going to sort of orangey buffy substance in. But the hex2N is going to make it colorless. So this is an addition. That's an addition reaction, and it will form 2,3 dibromine. The carbon doesn't go. Hexane, yeah, hexane. So it'll be carbon, 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 carbon. Whoops, carbon, carbon, and then you're going to have the sodium onto it. So that's the 2 hexene that's gone. So we've just got ethanol and hexa 1 amine to go. And we've got this acidified dichromate solution. And for that, we're going to check for an alcohol. So we get our 2 remaining pots, fill it up. It's going to have the ethanol and the hexa, whatever it is. We're going to put that chromium into it. The chromium acidified dichromate 2 minus. Ooh. And that into it, and then the same thing into that one. And we're going to notice something fairly amazing. This one here is going to go kind of green, and only alcohols will do that. So we'll know that this one is alcohol. This is an oxidation reaction. Your hint there is in this H plus thing here. So it takes up, and it's going to make ethanoic acid. So it's going to take that hydrogen. Good questions though. Question 2. Cling wrap is a polymer that can be made from monomer 1,1-dichloroethene. All right, for copyright reasons, okay. So I hope you all know what polystyrene polymer wrap looks like. And there is the monomer that it comes from. In the box below, draw 3 repeating units of the polymer formed. Oh, I guess there's going to be chloride, carbon, chloride, and then carbon, hydrogen, chloride, hydrogen, hydrogen, 1, 2, chloride, chloride, hydrogen, hydrogen. So the double bond is broken and it forms with the other one. So it just repeats over and over and over again. I think this is polyvinyl ethylene, I think. This is what it makes. But it's got to be that pattern there though. Okay, so explain why 1,1-dichloroethene cannot be a cis trans isomer. Well, the reason why is because it has a double bond. That double bond there, and that cannot twist or spin on its it's a wonky end, spin on its axis. So it cannot, so the chlorine cannot migrate. Okay, so I guess if you hit that, you always, for this one here, this chlorine here is not going to kind of swap sides, go over here. It's not allowed when you have that set up. However, we can make structural isomers that do have that structure. So we can't, if you notice, kind of here, we can't really pull this chlorine across. It was on the same carbon, but we can do this. This is going to be carbon carbon, and again I'm going to do carbon carbon. So now if we do, we can have that, which we couldn't before because both chlorines were on the same carbon. Okay, so this would be cis 1, 2, what was it? Dichloro, what's it? And this one would be trans 1, 2, what's it? You see here we had the double bond here. We had the chlorine on the same side, belonging to the same carbon, so we couldn't do that. Whereas here the chlorines are on different carbons. All right, so for this next question, we're told that we have propan 2-ol, and there is a reaction that makes it propene. So double bond is formed, and it looks like we lose some atoms, and it can be converted back. Okay, so what's gone from here? There's 8 hydrogen here, but there's only 6, so it is H2. It's been taken away from it, so this is a dehydration. So reaction 1 is an elimination reaction, most particularly a dehydration one, which has been used. What are the conditions? Well, we would need to add some sort of catalyst. We would need to add probably sulfuric acid, probably, and heat. That's that. So the CC has to form. So it's going to probably exothermic. Well, that's double bond. Then what does it ask? Explain why the reaction forms one single organic, but reaction 2 forms a mixture of organic products. Well, the reaction 2 forms different alcohols. So reaction 2 is what is that? That would be that would be just a straight hydration, which is an addition reaction. And when we do that backwards reaction, we need to heat again. We would need to add, I think, acidified water, I think, maybe what we need to do, or sulfuric acid again. So excuse me, acidified water, that's with our extra hydrogen and some acid, probably sulfuric acid. Then this addition, it's a hydration addition reaction. Why does it form two? Well, it can form two isomers. This OH can be either on the first carbon or the middle carbon. So maybe just to recap a bit clearer. So reaction 1 is an elimination, and it's a dehydration. So it would be, what is this? Propane 2-ol, and that's with SO4 and heat, I guess. Heats and everything, and it's going to make, what is it going to make? Propane plus H2O as byproducts. So it's in brackets there. Okay, the other way from the, so that forms a double bond. So the other one is from propene the other way to alcohols, and that also has H2SO4. It's probably also got H2O with an extra ion, and that's going to form two different alcohols. It's either going to form prop 1-ol or prop 2-ol. So on to question 3. So here we've got a reaction scheme, and they want you to identify A through D and what the reagents X and Y are. So we start here with propane 1-ol, and we add this chromium 7 ion, which has been acidified, to it, and we've kind of already done something like this. This would be propanoic acid. And what's the thing going to look for that? It's going to be C2, and then the functional group. It's going to be the functional group because they want us to circle it here. Circle the functional group of compounds A, B, and C that you have drawn. Oddly, they don't want you to function surrounded by D. Okay. So propane 1-ol plus 2 reagents gives you propene. So I guess we better find out what these propenes are. This is going to be some type of concentrated acid. So I'm going to say just concentrated H2SO4. And reagent Y, it's going to need to be a base. And it's coming from here. But I don't know what here is. So let's find out what C is first. So we're adding a Cl2. So this is going to halogenize it, which means it's going to become chloropropane. Yeah, that'll do. And we'll put it on the last one. So it's going to be CH. How many is it going to have? One. It's going to have 2, and then a chlorine, and it's going to make multiples, so we're not going to worry about the coefficients. Okay, so from that, what did we get? we get sodium, potassium, we'll say sodium hydroxide is an alcohol, and that's going to make propene. Okay, H2 in a catalyst, so the ene becomes an ane now. It's going to, so D, if it loses a hydrogen, if it loses this hydrogen under heat, it's just good old propane. So that's probably why propane didn't have so it's CH2. Monkeys eat peeled bananas. It doesn't have a functional group, so that's why ABC don't only need functional groups. So the functional group here is going to be this chlorine. Now what's it going to make? We're adding ammonium to it, so it's going to become some amino group. And what have we got to work with? Still prop, so still 3, so it's going to be propane 1 amine. So this is all one word, and we're going to put it at the beginning. So we've got CH3, that's 1 carbon, 2 carbons, 3 carbons, and then we have that amino group, hydrogen, NH2, circle that, it's that, it's that. Oh, okay, so the reagents I have an alcohol. I guess you could also have, as long as it's an alcohol, reagent Y. Oh, so that's Y, and X was concentrated, so it's nice and clear for the marker. That's what they were. So apparently this is the last question. Ethene. Gas reacts with aqueous potassium permanganate solution, which is this down the bottom. Dilute acid, H2O with a positive ion, hydrogen ion, and hydrogen bromine. Now the first one, okay, so they want you to describe any observations you may identify with reasons, the type of reaction it undergoes, describe the functional groups formed, etc., etc. Okay. I put up a picture of potassium permanganate because it really does look like it's raspberry flavored or blackcurrant flavored drink, Ribena. You do not want to drink this. It's a weed killer. If you have little kids, don't let them near it. Okay, what's going to happen when you add the gas? So you would blow bubbles of this ethane gas. Well, maybe you wouldn't blow them, but you would pipe them in. You're going to get like a brown kind of rust color sludge, really, down the bottom. Okay, it's because this is an oxidation reaction, and you're going to be making, what are you going to be making? You're going to be making two of those, and I guess you're going to be making, what are you going to be making really? You're going to be making CH2 plus some oxidation, plus, what else would you be making? Plus water, I guess, yeah, plus H2O, and you would get to that double bond is replaced, but there's hydroxy in there, that H2, but there is a hydroxide in there as well. That's what you would get if you added that. Now, reaction 2, we add the acidified water, just water with an extra extra protein, really. Proton. So this is going to form an addition reaction. No change in color, I don't think. It's going to be clear. I don't think you're going to smell anything. Might not. Don't think so. And you're going to, for the double bond is going to be broken. Isn't it? Yes. And we're going to add a hydroxyl group times 1. So when we do that, our reaction, it's going to be CH2 double bond, CH2 double bond, plus H2O, and the hydroxide is the catalyst, really. And then we've got CH, so it's going to make an alcohol, ethanol. Is it the last one? 3 is hydrogen bromide. Reaction 3 plus hydrogen bromide. What's that going to make? That is going to make bromoethane, isn't it? That double bond's going to be broken. So CH2 double bond, CH2 plus hydrogen bromide. There's not going to be any catalyst. So what's it going to make? It's going to just make one single result. So CH3, that's one of the bonds taken. CH2, and that's the end of the exam.
Wait.
1, 2.
There's 2 now.